Another day in paradise. You?
Yeah, good.
Good. Cool. So we're going to talk about rewards today.
Yeah.
Um,
And are we going to clean up the external and permanent loss as well?
oh yeah, I actually spaced that one, but yeah, that's a good idea.
I don't really have a spreadsheet for it. Would you mind just demonstrating it in the simulator?
Um, sure. Maybe since I've planned for the other one, do we want to cover that one first and then and
Let's
then
cover that one first.
follow
That's
up
a good
with
idea.
the impermanent loss? Cool. Um, I can open up the notebook, or do we want to start out with the BIP 15 rewards?
Yeah,
Because
I'll
there's
start with bit 15 and do a bit of preamble.
cool.
Um, okay, are we recording?
Yep, good to go.
Okay, great. All right. Um, so I guess, yeah, today we're going to discuss the rewards mechanisms. So during the design phase of Bancor V3, this was obviously something that was extremely relevant in its own time. And one of the main product offerings that we wanted to have, which was sort of lacking from Bancor version 2, was the ability for external teams to provide their own rewards, as well as for Bancor to provide its users with a rewards program. Bancor has ceased its rewards distribution for users, but other teams continue to have their own rewards. We know that Crown, for example, is using the auto compounding rewards program, and Arable are both using this feature. So it's still alive and well, and definitely worth knowing about. The section in bit 15 is just entitled rewards mechanisms, and you can still access this via the discourse on governance. The thing that we really wanted to sort of rectify with respect to how rewards programs were running, not just on Bancor for its own users, but for rewards mechanisms across the industry in general, is that there are sort of these redundant cycles. Certainly for BNT on version 2.1, we had a redundant cycle where the rewards that a user named Alice here, she would basically be given sort of a permission to mint tokens, and she would request that from the protocol, which would then mint that BNT for Alice. This is the inflationary aspect. And then for her to compound it, she would immediately put that back into the pool, which would cause the pool to withdraw its own BNT and burn it. And so you can see that there is there's a huge redundancy here that really didn't need to be there. And so what we really were trying to do is just create a system that would be, infinitely less gas expensive, but also more convenient for the user, and also address things like tax implications, for example, which was a very big, something of a rude awakening, I think, for many people participating in DeFi over the last couple of years. And so we envisioned a process where the protocol could actually just burn pool tokens, and that those pool tokens, because they're no longer there, would sort of distribute their value back to the user now, just because the protocol no longer has a share of that pool of capital, which means that on a pro rata basis, the users who still have their pool tokens are now entitled to a greater share of it. So the mechanism is actually pretty elegant. There is some aspects to this that we need to consider. And so, before we get into how these calculations are performed, I also want to bring attention to the fact that we were aware that reward schedules was something that kind of happened in DeFi a little haphazardly, right, without much attention paid to the future. And we can really learn from some of the most prominent, most successful cryptocurrencies that are still using rewards programs. Things like Bitcoin and Ethereum, right? Until very recently, actually, I think even until today, Ethereum is still technically an inflationary token. Bitcoin continues to be an inflationary token, but that doesn't mean that the economies for those assets is necessarily harmed by it, or at least it's not irrevocably harmed by it. And one of the mechanisms that Bitcoin uses is this idea of an exponential decay. So on Bitcoin, it's very it's very stepwise, right? People know about the Bitcoin halving, and it's this big sort of cultural phenomenon. But there's also a way that you can do it continuously over time. And that's represented by this equation here. This actually, I took out of my radiochemistry textbook, and it works precisely the same way to distribute rewards as, as the radiation profile of a radioactive element would decay over time. And so what I'm going to, I've actually got a spreadsheet for where some of these, where some of these profiles are created. I can open that up. Right. And so we can get into a little bit about what some of these numbers mean and how they, how they relate to rewards distributions. So essentially, we know that there's, smart contracts can't trigger themselves. So there's always going to be gas associated with some operation. And yet the rewards program on Bancor is actually gasless, right? In the sense that the users who are benefiting from it never have to pay the gas for it. And the reason that that's the case is that there are other network operations that are connected to trigger it. And because it's such a small gas expense, it really doesn't affect the network that much. It's connected to something called the Bancor vortex, and so whenever that mechanism is triggered, it also triggers rewards distributions. Now, because the rewards distribution can't be known ahead of time, with any accuracy, you can get a profile that would look something like this. Okay, so here what we're looking at is the rewards distributed in a random block. And so, over time, you can see that sometimes the rewards spike up pretty high, and then on another block, there's almost nothing at all. And, it looks pretty noisy, and there doesn't really seem to be any trend here. And so what this is simulating is I'm basically just taking blocks here on the left. I'm choosing a random number between 1 and 100 and adding that to the last block in order to calculate the next block number and so on. But how the rewards distribution works and why we don't care about how fuzzy this thing looks is that we take into account when the last block was where rewards were distributed. So what this means is even if several hours or days or something passes, it really doesn't matter. Whenever the rewards is triggered again, it compensates for that time lapse. So it actually sort of knows about how many rewards should be distributed and when the last time rewards were distributed. And this means that over time, we get a profile that's actually very predictable. And so what I've done here is I've taken that same process and I've just let it sort of run for, a few 100,000 blocks. And you can see we actually have this very, very, the line is a little bit rough, but nothing too major. And you can see the rewards are slowly being sort of siphoned down over time, right? So just in case you can't see it on your screen, we're starting at about 8 rewards per block. And over the course of, however many blocks this is, it's only moved down to about 7.9. That's because we're using a very, very slow exponential decay profile, similar to the Bitcoin mining, Bitcoin halving or something like that. And when we zoom even farther out, like this, so this is now looking at rewards distributed over weeks. You can see that it really does have this beautiful slow decay slope as it slowly winds down over time. And so this was this was economically motivated by the need to eventually, wean the industry off of liquidity mining programs, but still recognizing that they serve an especially important role, both culturally and in terms of engagement and community. And it's not worth necessarily throwing those things away. but that, we can handle these things in a much more, a much more educated way, I suppose. And so there's two different ways that this can be done on Bancor. So the first one is this exponential decay profile, and it's the one that I personally recommend. But of course, there's also the linear decay profile, and that is also, I think, let me check, should also be described in the bit 15 proposal. Okay. Now, with regards to this, this burning of tokens, we can work out how many rewards we should distribute here, and the number that you pull out of this at the end will tell you how many rewards should have been burned up to this point in time, or how many rewards should have been distributed up to this point in time, rather. But it doesn't tell you how many pool tokens to burn, and that's what this equation is. And so this is this is actually related to a common paradox, where if you say to someone that okay, let's say a potato, I think is the one that's commonly used, or tomatoes. Let's say that a tomato is 99% water, right, and only 1% mass other than water. And so the concentration of tomato per water is only 1%. How much water, or how much mass would you have to evaporate from the tomato to increase that concentration to 2%, right? To remove sufficient water such that only 2% of the mass of the tomato is something other than water. And most people will say, oh, okay, you only have to evaporate 1% of the water off, and that's the answer. But the actual answer is you need to evaporate off substantially more than that. So in this particular case, because we're trying to increase the concentration of tomato by 2x, that means you need to evaporate off half the water. So if you do increase the concentration that way, it means that you're going to have half as much of total tomato mass than you started with, which is a surprising result if you haven't had to deal with these concepts before. And in a way, burning pool tokens is very, very related to that. And this calculation here will tell you precisely what that number is, and this is already hard-coded in the contract, so you never actually have to perform it yourself. But if anyone is looking through our documentation, or looking through the GitHub, or looking at the contracts themselves, and they see this formula and wanted to know what it is, I just wanted to let you know that this is precisely the answer to that riddle. In terms of how many pool tokens need to be destroyed in order to transfer a certain proportion ownership of the remaining capital to users from wherever the reward source was. So that's what that equation is. And I think, this is just a really quick figure that demonstrates precisely what this looks like. I think it's pretty self-explanatory, so if anyone wants to dig into that, I'm not sure that it needs any further comment. And so, with a view to keeping this call as efficient as possible, I'm going to stop sharing my screen and hand it over to Mike.
All right. I'm going to share mine. And so, I'm going to go ahead and stick with, can you guys see my screen okay and hear me?
Yes.
Great. I'm going to stick with working in PyCharm here. This is my preferred IDE, as they say. So it's a Jupyter notebook, just with a little bit different, look to it, just because of where I'm running it. So if we open up, this is a new notebook that I put together this morning for this particular session, and it's pretty simple, right? So we're going to start out same way. We're just going to create one user today. We're going to whitelist just one token, which is TKN. We've got Alice, who's going to get a million of each TKN BNT to begin with, and then we'll just kind of start out going through a couple of steps, which which you'll see over time how this progresses, right? So we're basically at each timestamp. Well, we start out with 14, and then we just go by multiples of 14 with each kind of transaction is the way that this progresses. Here, Alice is going to deposit 1,000 TKN. So we can see these balances transferred into the staking ledger and out of her wallet. And she's going to do another deposit here. And then here we're going to just demonstrate, if the bootstrap requirements are not being met, we've just put a little catch here to print out, bootstrap requirements are not met for TKN, right? And so we go one more timestamp and add another bit of deposit, and then we call enable trading again. This time you can see that there is no error. Everything went through as expected. And from that point, we can import just a quick value from the repo for the number of seconds in a day, and we start creating first of all, we're going to start out with a simpler case, which is the flat rewards program that Mark discussed a moment ago. And so the way that we can do that is just by calling this v3.create flat AC rewards program. We can specify what the token is that we want to create the program for, the username of who's creating this, right? In reality, this is kind of done by the protocol, but for the purposes of here, we're just going to say it's Alice. Total rewards are 10,000 is what we're defining up here, and a start time, total duration, and then the current timestamp. So once we do that, we can scroll down and do our balances here, and if we come down somewhere here, rewards vault, we can see that actually there was a BNTKN rewards vault balance added for the amount of $10,000 such as specified. And if we flip the timestamp again, we can then run process auto compounding rewards program, and the name of the token that it's for, and then the timestamp, which I believe is it's progressed 2 times since the previous, since it was created. We can now see that some of the rewards have been distributed, and so that's exactly what we want to see, right? Now we can keep going through over time and see just how this number drops with each timestamp. I think these are just incremental, so like 14 by 9, 14 by 10, and you can see it just changes a little bit each time. 14 by 11, same thing, a little bit here, and of course. The balances of Alice are changing as well. The one of these here, I'm going to try to skip ahead because this is kind of redundant. But you can get the sense that you can follow the balances that are being increased, and this looks to be an error here. So I'm going to just run this whole thing one more time. Oh, I've got a bunch of these errors. So I'm going to do a quick troubleshooting here, and I'm just going to say find each one of these and just make it one of those. And in Jupyter, you might have to just go through the replace all. It doesn't seem to work that well sometimes.
The replace on Jupyter sucks.
Yeah.
But on VS Code it works really well.
Really? Yeah.
VS Code it even sometimes works too well.
Well, that's good.
You can find yourself replacing things that you've forgotten that you were still using them in some other function.
Yeah. So I kind of lost where we were going here, but now I want to kind of scroll down into, okay, so here we jump way ahead, right? So we went from like timestamp 14 by 21 to 210, right? And then we can look at, how much these balances are changing over time, which it's like, it's actually not super fast, right? It's quite slow. So 2100, now we jump ahead again, and you can see, well, that one actually did have, we went down actually 9 tokens that time, so that's a much bigger jump. And so on and so forth. So you get the idea. There's an SDAP. Oh, all pool tokens. V3.
One of the cool things to do with this, by the way, is to set the timestamp like super far ahead of time, and trigger the rewards distribution, which is the burn pool tokens function that you can see there, and then just like withdraw a user's tokens for them. It's just a really gratifying way to see the rewards program actually working exactly how it's supposed to be. And it was one of the things that I just got really excited to see when we first got it into the simulation.
Yeah, agreed. And this is kind of a fun notebook to play with, right? Because it's a bit long to scroll through, but it pretty clearly demonstrates what's happening. And eventually we do. What is this? Trading is already enabled. Okay, so I'm going to run this once more, but we're getting up to the point where we're now going to create an exponential rewards program and see the differences there. I'm not sure, did I pass that one? Okay, there we go. So now you can see the last one we called was create flat AC rewards program. This one is create EXP for exponential. Otherwise, the inputs are similar. We have this term called a half-life, and that comes from the equation that Mark was just discussing previously. So
maybe that needs just a brief comment. The half-life is really easy. It sounds like a scary term, but it's really not. It's just how long it takes for the total, the total rewards to be given out to reduce by 50%. And this is a constant. So if you set the half-life to 1 year, then that means that half the tokens will be distributed in 1 year. It also means that half the tokens will be distributed in the next year, and the next year, and the next year. So it's like, if you've got 100 tokens to distribute, you set a half-life for a year, there'll be 50 tokens left after a year, then 25 tokens left after 2 years, then 12.5 tokens left after 3 years, and so on. So it's it really is very much akin to the Bitcoin halving, if you're familiar with that, which I think is a 4-year cycle.
Right. I'm noticing here that Alice is quite broke at the moment. But nevertheless, yeah. So be aware that when you're running a simulation, we've gone back and forth about whether to throw an error on this or not. And I just, in the process of setting up some of these tutorials, it's just easier if you can kind of do the transaction that you want without getting error messages, especially when we're doing some live sessions. So, but just be aware that if you do see this, you should just give Alice some more money. So the same concept, right? It follows here where we go through the same or similar process, and stepping more. I thought I fixed all these this morning, but this notebook's so long that I apparently only made it part of the way through. So anyway, that's more or less the gist of how to use this simulation tool for rewards. And like Mark said, there's some here we do another, we create another one here, based on some of the balances that are in the system at the time. And okay, let's see if it'll run all the way through again. At the very end, we can see the amounts, right, that are left, and yeah, that's pretty much what I want to demonstrate. I'll go back and I'll give Alice some more money, and then post this. I did put this notebook up on GitHub already, so if you're watching this, you can find it there as of now, but I will also push up a new copy that has the adjusted balances, so hopefully you don't run into the negative errors. But I think that's, we're about good on time for today. I was looking at, I think this is the last, we've got one more session scheduled on the Discord that I see, and perhaps with that last session we can do a walkthrough of the proposal that David Meister put up, which kind of puts all the different pieces together. Not everything, right? It actually does not include rewards, and some of these other things, but it will tie together, like, well, okay, how can we, randomly generate different user actions based on these things, and we can try to tie some of the concepts together, as well as look at the IL protection in a bit more detail. Which, now I'm thinking about it, I'll just I'm not even sure that I have an IL rewards demo ready, but I can run through like where that balance is being kept. In fact, let me look at one thing. Maybe we do have so standard rewards, claim standard reward, process, terminate. Yeah, I don't know that we've got an IL protection example. So like maybe for next time. What's that?
The external IL protection?
Yeah.
Yeah, cool. All right, let's put that in there then. I might also either I can do it on this one, but I also thought it might be fun to look at the pragmatic notebook that they had the Monte Carlo simulation, with like all the printouts and stuff, or like I actually want to run like a chaotic sort of noisy system and sort of let all the fields populate and see it carrying on as if it was a little contained ecosystem unto itself, with people performing arbitrage using the price feeds and all of that kind of stuff.
That's exactly what I'm also talking about with the David Meister's proposal. We have like a pre-built notebook which does that, but just using that data. But also good to look at the pragmatic one as well, which is
I was going to say because I know that certainly, like, some people are watching these videos to learn a little bit about like, programming generally, and also like creating simulations. And
when you guys say, oh, sorry, I
no,
just
go
wanted
ahead,
to ask you a question. When you guys say we should add external IL, is that like a template that anybody can use? Like, even if they don't quite understand every aspect of the simulator, like can other project teams take that and do simulations off of a template?
Yeah, well, it'd be like kind of the same thing we just went through with the auto compounding rewards. There's basically
Yep.
the same ability to do. So you don't really have to know what's happening behind the scenes. You can just kind of run some basic simulations like that. Yeah.
And it's actually already
That's
there, right? The external IL, like the external IL protection logic is already a part of the simulator. We just don't have like a demo of it.
Gotcha. Yeah, that's perfect.
So yeah, we should have that. But yeah, then I thought, just a good way to wrap it up would be to kind of show like where the simulator began with my shitty programming, and how to start looking at like that huge like nested dictionary that I created, and then have you comment on how like this is much better represented as a class, and that kind of stuff, right? Just to kind of tie up loose ends and give a more sort of pedagogical feel to it before we close up.
Yeah, I agree. That maybe that last session we can plan on it be like a little bit longer than usual, just because like kind of pulling it all together might be a little bit more than 30 minutes, but
yeah, that's true.
Cool.
Quick question.
This is like the most important. The last one's the most important one to me, because it should be as long as it needs to be to kind of communicate the value, I think.
Yeah.
Completely. Cool.
What were you saying, Jen?
Quick question. On Monday, you mentioned tentatively having 3 more sessions. They're not scheduled yet, but will Friday then be the final, or do you still want to do extras?
Oh, that's interesting. Yeah, I guess I wasn't paying close enough attention. I thought you had already added them on Discord. So as far as I know, I'll look again at the schedule, but I think that this rewards session was kind of the last one that we had planned. So I don't think we need 3 more necessarily. We probably just need like, one more long one.
Be nice.
Or something. Yeah.
Well, what might be nice is because we want to start talking about some of the new product stuff, and obviously there's a lot of simulation stuff going on already, and pretty soon we'll be in a position to start presenting that kind of stuff, and so we can actually start talking about some of these features. Like there'll be the normal sort of the normal avenues where we start talking about the high level product features and what you can do with it, but then other people might actually be interested in like the math or the the logic behind it, or how things work, and we can actually kind of continue the simulator these simulator discussions in that way, so that people